Hello everyone, welcome to Accounting 312. In this video, I want to talk about our Excel project, your group project 2, and also chapter 10. I believe when you are watching this video, you already have watched the other video I let you watch before starting this project. So you should have a general idea about regression models and then some terminology, right? So what we want to do in this video is I go through the group project with you, but I don't really give you the exact same number, but I show you a very similar example, and then we go to the requirement step by step. Hopefully, this can give you a clearer idea since I cannot see you. So let's get started. Okay, so if you go to Blackboard from coursework, you can see all the materials are already there. I haven't made it available yet, but I'm going to do it soon. So have PowerPoint handout and then learning objectives, and then we use this Good Belly case. Actually, it's a real company. So I suggest you read the case first and also discuss with your group members, email them, text them. So this is a real company. The way I held this project is I actually bought the drink is making drinks, and then students you can drink it and taste it, and then we have this project. I'm sorry, we don't have the chance to do it together this time, but I don't know you have heard it, yes or no. Make sure you go to their website, get some general idea, and then they also give you free sample. You can try, but get a general idea so you know what you are trying to do. So read the case, right? As I always say, don't just go to the numbers. You want to read the case, have some general idea what you are doing. So they are thinking about how to increase their sales. They have different activities. So your job is you have all these variables. So this is our dependent variable. We want to know what will affect our weekly sales, which is the volume. And then we have all these independent variable, right? This is all the X. And we run regression model, we found out, hey, which activity can affect our dependent variable, which is the weekly sales. So you go to the Blackboard, I provided the raw data in the Excel file, and then I also give you step by step how do you perform the regression analysis using Excel. I'm not sure you have tried this, yes or no, and then I'll give you the requirement. So I already downloaded the file, the data. I want to explain this variable first. Okay, so some students they got a number, but they don't know what does the number mean. That's not proper because we are not statistics. I keep telling you we are accounting. We want to know the story behind the numbers. This data came from 126 whole food, there are so many observations. So as I say, our dependent variable is weekly sales, that's our Y. And then we have average retail price, right? Average retail price. Sales representative, what's the meaning of sales representative? This is a dummy variable. If you don't know what dummy variable, you can Google, you can read a little bit other explanation, or you can just YouTube dummy variable. General idea, dummy variable is either 1 or 0. So let's say, do you speak English? Yes or no, right? You speak is 1, you don't speak 0. So let's say, are you 6 feet tall? Yes or no? If you are, it's 1. If you are not, it's 0. So it's just the two variables, either 1 or either 0. So sales representative, so if there is regional sales representative, then it's 1. If there is no, then it's 0. We have a lot of dummy variables actually. End cap, demo, demo is a little bit different from the sales representative. They have a demo the same week, 1 to 3 weeks ago, 4 to 5 weeks ago. and natural retailers, and then fitness center. So make sure what's the meaning of all these variables, okay? Now you got all this raw data, and then I ask you to do all this. I said, hey, you first run the regression using all the variables, and then you run the regression only use the significant variable, and then write your report. So what I'm going to do, with you just to show you a general idea. If you already know how to do a regression analysis using Excel, you can just skip this part. We have the data, we have the region, we have the store. We don't really worry too much, but we have all these variables we want to figure out, right? One more time, unit sort is the dependent variable is the y, and then we have all these independent variables. So what we should do is you go to the data part. Let me see whether I'm right or wrong, and then go to data analysis. So as I already told you, group project step by step. I already did the screenshot and then showed you how do you add it. If you don't have this data analysis, you have to add it from the options, and then how do you get a regression analysis. That's what I'm doing. So either you can read that file, you can watch the video, data analysis. So my computer is very slow. Let's give it a minute. Okay, give it a minute. Hey, come on. Okay, you have all this. We go to find the regression, and then you click OK because we want to do regression. Click OK. Y, we want to make sure our Y is, I think I'll just click all the way here. You have to select all the variables. Sorry. Well, this is Y. And then my X is all the way from bottom to all the way to top. And then we have several variables, right? And then I include the label there, right? So because I already select a unit sort, I already selected that. So you have to click label. Constant is 0. No, it's not. Confidence level, we make it 95%. And then output range, new output sheet, maybe new workbook, okay? We want to see the residual. We want to see this. What did I say else? Let's see. Sorry, it has been a while. Okay, sorry. See, you have to prepare, right? So I click here, I click label. But you can use either one, residual. Okay. So I selected this. Okay, so I click OK. Okay, so I click OK. Hey, I should give you a different. range, but oh well, I selected the right. This is the answer, right? I selected the same observation. So in the example, my intention is give you a different number. But in the example, I only selected 299. As I said, this is just the example. But in the video, I just to show you the right answer here. So free bonus, all right? Free bonus. I selected 1,386, which is right because you see the explanation told us we have 1,386. So it generated a new table there. So what we need to do, So first you show me this Excel file, you don't need to print it. So it's very clear. You just need to show me this exactly the same thing. And then what do we need to do? Okay, what do we need to do now? Since we have the right answer here, give me 1 second. I want to show you something. Okay, so let's say this. What you need to do, as I say, first check whether your observation is right or wrong. It's right. And then we check the R square, right? We check the R square. I don't know you have heard R square, yes or no. But R square basically means the percentage Y, the variance of Y can be explained by the variance of X. You want this number to be larger. Larger is better. So R square, since it's a square, it's definitely not negative. So R square is between 0 to 1. Highest is 1. So it's between 0 and 1. Higher number means better. That means your model can explain basically the why. How do you understand R square? So just to think about the opposite of R square is the error, is the residual. So you want the error to be small, that means R square will be large. Then you look at those, you think 67% is not really bad. I personally think it's fine. Some textbooks said it has to be 85% or something, but in the reality, really hard to be that large. So I think 67% is not bad. And then we then look at this part, right? We look at this part. So you have something called a coefficient. You have a coefficient, you have standard error, you have t-statistic, p-value, and then all you need to know for now is you definitely need to know the coefficient, and then you also need to know the p-value. P-value is related with the t-statistics. So those two, you just need to know one. I personally suggest you know the p-value. Okay, so coefficient is number one thing you need to know. From the coefficient, we can write our regression model. So hey, since we are already here, I can just write, I leave it for the next one because this is not our final model. Okay, so you look at all these variables. Remember, how do we explain is, let's say, average retail price, you have this coefficient. So that means when your retail price increases by $1, your predicted, okay, it's not the actual, it doesn't mean you go to one specific store, the actual units will decrease this amount. It's not, it doesn't mean that. The meaning is, remember we found 10 weeks and then we look at 126 store. The regression tells us on average of these 10 weeks in these 126 store, what will happen. It doesn't mean each specific, like St. Louis Whole Food. No, it doesn't mean that. So you have to tell me the keyword I'm looking for is predicted on average, you know, that word. So you can say, hey, when the average retail price increases by $1, your predicted or on average, the units, right? We are predicting the units that will be sold. The units, sold unit sales volume will decrease by 28.53 units. Okay, so that's the units, it's not dollar amount. Your predicted volume will decrease by almost 29 units, 29 cases or 29 bottles. So this is how do you interpret the average retail price. And then you will say, hey, Professor, we have something called dummy variable, right? Remember we said sales representative, end cap, demo 1, 2, 3, demo 4 to 5. So those are dummy variable. How do we interpret those dummy variable? Let's get one. So sales representative, remember, it can only be 0 or 1. So what does that mean? When there is sales representative, when there is sales representative, that means sales representative is 1. So when there is sales representative, the predicted, the average, you know, sales compared with no sales representative. So, you know, when there is, it means it's 1 compared with there were no representative. That means when the value takes 0, right? So, hey, are you 6 feet? Yes or no? So the 6 feet guy compared with the not 6 feet guy, right? So when there is a representative compared with no representative, on average, the sales volume will increase by 77 units. Okay, end cap, one more time, right? When there is end cap compared with there is no end cap, the predicted sales will increase by 305 units. And then you do the others, you know, just do it by yourself. Natural stores, right? You make sure you know the definition, natural retailers. So that means, you know, when there is, let's say, what's the definition? The number, okay, within 5. So if there is one more natural stores, right? If there is one more natural stores, the predicted sales will decrease by 1.59 units. When there is one more fitness center, the predicted units will decrease by 1.01 units. Okay, so that's basically how do you interpret. What I'm trying to look at is make sure what are you predicting is the units. It's not dollar amount, it's the units. And then it's always our predicted on average, the number. It's not specific. Hey, if I ask you, hey, give you this number, I said if you go to Santa Luis Whole Food, and then if there is representative, the exact units will increase by 77 units. No, that's not right. Okay, so we look at coefficient, and then we look at the p-value. We want p-value to be smaller. We want p-value to be smaller. Our cutoff is 5%, 5%, which is 0.05. I don't want to explain too much about p-value. If you are good at the statistics, you know, or if you want to learn more, you definitely can Google about p-value, just showing our statistic significance, whether it's significant in our statistics terminology, yes or no. And as I say, our cutoff is 5%. We want the p-value to be smaller. We want our p-value to be smaller. We want the p-value is 0, honestly, 0.0000001. Smaller is better. Smaller means it is statistically significant. So if you look at all this, you will find out we only have 2 variables that are not statistically significant because p-value, they are larger than 5%. This one is 37%, and this one is 35%. Those they are not significantly significant. They are not statistically significant. And then in the requirement, I ask you, what do I ask you? Which variable are significant, which are not significant, you should know. I'm not going to say this. I want to see your reason. You think why they are not significant. So why natural retailers or fitness center, they are not related with the units of sales. Give me some story. You tell me. You think why they are not. What's the meaning of why they are not statistically significant? It just means they don't really change. They don't really affect our sales. So if there is one more natural store or one less natural store, you know, one more fitness, or we don't really care. You know, right? Hey, if there is a fitness center open, should we be worried? Oh, that will affect our sales. We don't worry. It's not statistically significant. But I want to ask you why you don't think the fitness number will affect our units? Why natural store will not affect our units? Okay, so that takes care of the first part. I don't want to make a too long video. I think I'll stop here. Then we talk about the other paragraphs in the next video. Thank you.